everybody. We are going to review today what we started talking about on Monday about perpendicular lines. So let's all look together here at line A. We can very easily write an equation for line A because we can quickly identify the y-intercept. So we see that the y-intercept of that 1, 2, 4, 5, 6, 7, and the slope goes down 3 over 1, which makes the equation y equals negative 3x plus 7. In line B, we can't easily identify the y-intercept because it's not an easy to read point. But I can easily see that there's a point here at negative 1, 1, and that the slope, if I count my rise over run, is up 2 over 1, 2, 3, 4, 5, 6, and so that the slope of positive 1/3. I can now write my equation in point-slope form because I have the point and I have the slope. And if I have the point and the slope, we all know we can write an equation in point-slope form. So here's what we've got. Y minus 1 is equal to 1/3 times the quantity of x plus 1. We know that if we have an equation in point-slope form and we're going to be comparing that to another equation, we need to transform this to slope-intercept form. And so we're going to distribute y minus 1 is equal to 1/3 x plus 1/3. We're going to isolate the y by adding 1 to each side. And here's what we've got. Y equals 1/3 x plus 1 and 1/3. If we compare the slope of line A, which is negative 3, to the slope of line B, which is positive 1/3, what you'll notice is what we talked about yesterday. Negative 3 over 1 is line A. Positive 1 over 3 is line B. And you can easily see that the slopes are the negative reciprocal of one another. When you take two slopes of perpendicular lines and put them together, and this should look familiar to you because we talked about this on Monday, what you're going to find is that the product of the two slopes that are perpendicular will be equal to negative 1. And another example is what we just did. Negative 3 over 1 times positive 1 over 3 would give us a product of negative 1. The only time that that will not happen is if we find the slope of a vertical line and the slope of a horizontal line. We know the slope of a horizontal line is 0. The slope of a vertical line is undefined. And therefore, the product of their slope will not equal negative 1, but it is pretty obvious that a horizontal and vertical line will form a horizontal line and a vertical line will form a 90-degree angle. All right, let's take a look at some of the questions that you will see when you try to do some of the classwork for today. Just like what you did the other night for homework, find the slope of a line that is perpendicular to the graph of each equation. So we're given 3 equations here. We're going to find the slope of a line that is perpendicular to this. So our given slope in this first example is 3, m equals 3. The slope of a line that's perpendicular to that, remember, is going to be the negative reciprocal. So a perpendicular line will have a slope of negative 1 over 3. Here in the second equation, we have a slope of negative 2/3. The negative reciprocal of negative 2/3 would be positive 3/2. So the slope of a perpendicular line will be 3/2. In the last example, it's in standard form. Hopefully, you're starting to remember that we find the slope of an equation that's in standard form by taking the opposite of a over b. So I know that a over b would be 3 over 4. The opposite of that would be negative 3/4. So the slope of a line that's perpendicular will be positive 4/3. Okay? If you need to pause so that you can jot down notes, go ahead and do that. I'm going to continue. The next part of the kinds of questions that you'll be asked for your classwork today look very much like the second part or the last part of what you did for homework the other night. Look at the wording. Sometimes it's a little bit confusing. Write an equation for the line that contains 1, negative 2, and is perpendicular to y equals 5x plus 3. So we know from this that we can identify the point and the slope, even though our slope of a perpendicular line will be different from the slope that we're given. And if we can know the point and the slope, we know that we can write an equation in point, slope, form, and then transform it. So let's see what we've got here. If the slope of this line is 5, the slope of a line that's perpendicular is going to be negative 1/5. The point is 1, negative 2, because that's what's given. With the slope and the point, we can write the equation in point, slope, form. That would be y plus 2 is equal to negative 1/5 times the quantity of x minus 1. Remember, our last step is going to be to transform that to slope-intercept form. So we are going to distribute that negative 1/5, and we're going to then isolate the y. So from here, we would have y plus 2 is equal to negative 1/5 x plus 1/5. We're going to now subtract 2 from both sides, and we're left with y is equal to negative 1/5 x plus negative 1 and 4/5. We'll do one more example, and then you guys are on your own. All right, same idea here. We know the point. We know the slope. We can write an equation in point, slope, form. Here we go. The slope of our new line is going to be negative 4/3, the negative reciprocal of 3/4. Our point is 3/8. We're going to write an equation in point, slope, form. Y minus 8 is equal to negative 4/3 times the quantity of x minus 3. We'll distribute, we will isolate, and our equation will transform to point or to slope-intercept form. So we've got y minus 8 is equal to negative 4/3 x plus, we love when this happens, 4. We're going to add 8 to both sides. And here's our answer. Y is equal to negative 4/3 x plus 12. That is everything that you need to know now about perpendicular lines. So you're going to do some exercises in your textbook that are just going to ask you about perpendicular lines. And then we're going to do some exercises in the textbook that will have you comparing equations and deciding if the line will be parallel, perpendicular, or neither. Behave yourselves. I know that you will. And I will see you guys tomorrow. Take care.